right, and we're back. Our next speaker is Blake Nancarrow. He'll talk to us about building a custom dew heater for your telescope lens.
Thank you, Paul. Uh, my name is Blake, and it's my objective to share with you how to build a dew heating strap. If you want to do astronomy in Canada, you need dew heaters. If you want to do astronomy for a protracted period of time, you want to do visual or photographic work, you need dew heaters. Some people think you only need dew heaters in the summer. No, you need them all year round. Anytime you have high humidity, uh, that's going to be an issue. Amazingly, from my backyard, I haven't had to run the dew heaters for the last 3 or 4 nights, just because the daytime humidity is low and the temperature is not falling terribly low. But if you have the temperature dropping low and you're getting close to, at, or below the dew point, then you're going to need dew heaters. And let me say right away, I just want to apologize in advance to Mr. Jim Kendrick. uh, I need to make some disclaimers here. I'm assuming you know which end of a soldering iron to hold. And if you do undertake some of the things that I'm suggesting, that you're not going to sue us if you burn up your telescope or your workroom. I do want to caution you. There are some risks here. If you don't do your math right, you could have a heating element that goes red hot or white hot, and that could burn stuff, set things on fire. You could burn yourself. There's a possibility. I think the risk is a bit low, assuming that there's fuses in place, but you might damage your controller for your dew heating system. So be careful here, and I'll emphasize later when you're doing the math, do some double checking and testing and so on. But and if you don't know what you're doing, if I hope you'll ask if you're not confident. People will help on our forums. There's at the end of this presentation, I've got some contact information. You can reach out to me, and I'll try to answer your questions for you. So here we go. Why do you want to do this? I have 2-inch dew heaters from Kendrick Astronomy based in Toronto. I've had several of them, in fact, and I've gone through a number of them. They have broken or failed. In general, I think the build quality of these products is good, but I wonder if they're just not robust for how a lot of us use them. If you have a permanent observatory and you're putting dew heaters on the telescope and they stay there for months or years, great. There shouldn't ever be any problem with those. But I think about when I'm doing observing and I take the 2-inch heater off of one eyepiece, put it on another one, and then change eyepieces again. So I take the dew heater off and put it on another one. Even though I'm trying to be careful, I'm trying to be gentle with it, I'm trying not to bend it or crimp it or things like that. And when I store it in the case, I coil it up very gently. I make sure it's not being pinched or compressed or anything. And I'm trying to be really careful, but they keep breaking on me. And I think inside them, there's some very fine wires that are maybe brittle or just can fail over time if they're bent the wrong way. So that was sort of part of the issue for me, that I recently ran into a problem again with one of my dew heaters. In fact, it was on an observing session about 18 months ago in the backyard. It was cold. That's not my telescope. But I had very cold conditions, and there was some frost on the telescope, and the eyepiece kept fogging up. And I had the dew heater wrapped around it, and I thought it was working okay. And I took my hand out of my glove. My hand was cold, and I felt the dew heater, and it kind of felt like it was working. It wasn't ice cold, but it didn't feel really warm either. So, to make a long story short, I tested it, and I found it was intermediate. It worked in a certain position and not in others. So I knew there was a bad heating wire or nichrome wire inside it. So, and again, this is not the first time this has happened to me. So I was frustrated, and I needed a solution. But I have some talent. I had almost all of the supplies that I thought I would need. In fact, I've been collecting for years nichrome wire from various sources. I'll talk about that in a bit, where you can find nichrome wire, and over the years I've looked at various designs that I've found on the internet, and sort of bookmarked a few of those, kept track of them. But I was greatly inspired by a particular design by an amateur astronomer who lives in the Philippines. I went looking for his website recently, and I think he redid his blog or he redid his website, so I couldn't find a bunch of things now. I couldn't find his article in particular, so I don't have a link for it. But at the time, I took the pictures. I thought it was really interesting, his design. So do you see what's going on here in this top image? That there's this plastic thing that forms kind of the core of the heater, and he explained that he got that plastic from just a file folder. He'd gone to a stationery store, he bought a file folder, plastic type. You can see it's sort of clear, translucent, and he just cut it into a strip. So I thought, hey, that's a good idea. Plastic core, that'll work nicely as long as it stands up to the heat. So that's good. And you can see that there's wire wrapped around it in this zigzag pattern. If you look closely, that's heating element wire and nichrome wire. And his wire is pretty fine there. And if I remember correctly, nichrome wire is brittle. So you don't want to bend it back and forth a lot. It might snap. Anyway, I like that design. But what I didn't like is all the electrical tape that he put on it. Here, I thought, after a while, I know that stuff gets sticky and gooey and maybe starts to move around or slide a little bit. So, but the reason he did that is he wanted to sort of to get the wires locked down. You don't want those moving around because you could get a short circuit, and that could change the heating output for this. So I was a little bit nervous about that if I was going to mimic this. I came up with an idea for sort of getting around that. So here's what I did. I took a plastic piece, clear sort of light blue plastic, and do you see the notches that are in here? I've put notches every little while, and that's meant to hold the wire in place without using big blobs of electrical tape all over the place. So that was just an idea that popped into my head, this sawtooth kind of design. And I even thought of another way to do that. You could have a hole and a slit in the plastic to kind of capture the wire in place. There'd be no way that it could move then. The wire that I've put around this is under some tension, so I do not think that the wires are going to hop out of their grooves at all. So I'm not worried about short circuits with this. So I was quite pleased with this sort of approach or this design. And Edney's design, again, I found very inspiring because I thought it's a really flexible system. And I don't know if you can make out the wire that I'm using here, but it's kind of crimped. It's a kind of a wavy line. And I'll explain why shortly, why it looks that way. But I know that this wire is really, really flexible. So I'm not worried about it breaking. It's quite heavy, robust wire. So I'm sort of happy with this approach. My friend Rhonda gave me a great idea for the plastic core. And in a moment of inspiration, I realized that I had something that I could use to make a casing that would provide insulation. Obviously, you don't want these metal wires touching any metal on your telescope. They have to be protected or insulated. So now the math part. Sorry if you don't like doing this bit, but if you do want to build your own dew heater, there's a few things that you need to know. You're going to need to perform. So you need to know your heat target, how much power you're trying to produce or output. You need to have a pretty good idea how long the heating element or nichrome wire needs to be, and you need to know the resistance of that wire and sort of take all those things together. Uh, um, so I looked at a bunch of dew heaters that are out there that are small for 2-inch eyepieces or 3-inch eyepieces or camera lenses, and looked at some of the different vendors that make them. And I found that they were producing anywhere from 3.5 to 10 watts. So that was sort of a target for me. Now you need to know your electronic theory forums. Formula here. So the voltage is squared, and the P is the power, your heat target, and that'll tell you the resistance that you need. And of course, I'm driving all of this, the classic sort of thing with telescope accessories off of 12 volts. So 12 volts squared over the power rating. I just kind of chose a number in between. I thought, hey, I'm going to go with 9 watts. So that means that the target resistance that I needed, 16 ohms. Now you got to be careful with this because you've got a power calculation here and you're doing division. So small changes in some of these numbers can make for big changes in other ones. So again, you want to be careful here when you're doing the math so that you don't light anything on fire that you don't intend to. Then I needed to figure out the length of wire that I needed. You saw that plastic piece that I made, and I had the sawtooth in it, and I put those notches in the plastic every 15 millimeters. I just randomly decided on that, and then that produced this zigzag pattern for the wire. And I counted the diagonals and the verticals. I had 16 of each. So that meant as I wrapped the wire around, I needed a total run length of 85 centimeters of wire. So now I had another important number. I had the ohm rating, I had the amount of wire that I needed, and then I went to my supply. I had a lot of resistive heating wire, and some of it was rated at 44 ohms per meter, and some of it was down to 7.3 ohms per meter. I chose a piece of wire that was 25.8 ohms per meter. And of course, I needed 85 centimeters of that. So 85% of that gave me an ohm rating of 22 ohms. I bench tested that before sort of building the whole thing, and put it on my controller and hooked it up to the battery and turned it on full power. And it was good. I was able to hold the heater, didn't burn my fingers. I didn't set my desk on fire. There was no new supernova in our solar system that couldn't be explained. So it was a good sort of test. So I knew my math was all good. So I had sort of everything that I needed in terms of the resistive wire. Again, Rhonda gave me the idea for the plastic core. That was like fantastic. I was explaining the project and see I needed some plastic, and I was thinking that I would go down to the dollar store and buy a few plastic file folders. And she said, "Here," and she handed me a empty bottle of sparkling water, this light blue sort of color. It was a really nice size. I knew it would fit a fairly large eyepiece. I don't know if any of you have those TeleVue eyepiece hand grenades, huge eyepieces, but I have some modest size 2-inch eyepieces, so it would work well for that. I've got some camera lenses that maybe have 7, 8, 9 centimeter diameters. So I needed something that would work in all of those kinds of different applications. But this bottle was perfect, so I just cut a slice of that out, 2.5 centimeters wide, and a neat thing about it is it was pre-curved. it was in the shape or the sort of the pattern that I wanted. So I was really, really happy about that, and free. So that was good. It was headed for the recycle bin. Um, I have done this for many years. Nothing terribly lately, but I harvested a lot of toasters, and I took the heating or the resistive wire out of the toasters. That's where that crimped wire came from that you saw in my earlier photo. Um, so if you've got an old toaster, it's dead. You can use that. I don't need my hair dryer anymore, so I took the heating elements out of those. A lot of hair dryers have coiled um, resistive wire, so that won't necessarily work for a dew heater application, but you might be able to use it for other projects. And of course, you can buy this stuff from electronic shops. Um, I bought some somewhere, and I've totally forgotten where I got it, but I got a good sort of length, and it was about $2 per meter. And if you buy it from a store or you buy it online, you can pick the resistive power rating or resistance that you want. So I started putting stuff together. Again, there's a snapshot of the plastic core. I've got my tape measure to hold it down because it wants to curl up into the original circle. It's got the memory in the plastic. I wrapped the toaster heater wire around it. And then another sort of moment of inspiration kind of thing that happened for the project is I realized that when I was out at the shed looking at a flat tire on my bicycle, that a bicycle tube would maybe be the perfect size. And of course, offer very good insulation. I have two bikes. I have a racer that's got tires that are less than 1 inch, but the mountain bike tire or tube size, 1 3/8 of an inch tire size, was great. That was a really good size and fit around the plastic, forming this very good sheath and offered a bit of structural stability to this as well. So that was good. You need to get power to the heater, so I wanted a cord that was pretty flexible. Years ago, I was at Active Surplus down on Queen Street, the orange store with the gorilla, and I bought a long length of speaker cable, and I can't remember if it's 2 conductor or 4 conductor, but it's got this great jacket on it. It's really nice soft rubber. It's very flexible and cold. So obviously you need 2 conductor wire to get the power up to the heater. I have found with the stock or commercial dew heaters, the power cords are a little bit short. Sometimes they're not quite long enough, or there's the danger of stressing or snagging a cable. So I deliberately made the power cable a little bit longer, about 1.5 meters. You could use lamp cord. You could use speaker wire. That would be fine. You just need to make sure it's a good gauge. You don't want to use really fine, thin wire. You want to use a large gauge because you don't want any heat produced in the wire. You just want to transfer all that power as effectively as possible. All this stuff, I had all this in my part bins. So I actually didn't have to go out and buy anything to make this this dew heater, including the little bits and bobs. If you're plugging into a standard dew heater controller, you need an RCA connector, RCA jack, an RCA plug to do that. And then there's various supplies, electrical tape and stuff. Another little thing that I did is I put aluminum foil inside the dew heater so that it forms a reflector. It's on the back or the outside edge. So I'm just trying to keep a little bit of energy directed back towards the eyepiece. And I made a fabric cover for that. So there's a few dollars there. Maybe if you had to go out and buy all these parts, maybe, I don't know, $15-20 you're looking at all told. Again, for me, I had everything, so I didn't sort of spend a dime. It was just my time. You need some tools here, of course, for this. I used various tools that I've noted here. Again, hopefully it's clear. You want to be careful about the math. So you need an ohm meter or a digital multimeter. You can do an additional check and use an amperage meter as well. Make sure it's at the proper power rating, because you might be producing 7, 8, 9, 10 amps of power. That's a lot. So you want to be careful. And I sparked up the sewing machine at the end to make the cover for this. And there it is, all done. You can see I've got the fabric cover in. Immediately below the fabric cover is the bicycle inner tube. That's around the plastic sheath. The plastic core has the wire around it. On the outer surface of the bicycle tube, there's a piece of aluminum foil, again acting as a reflector. There's my microphone cable and an RCA plug. And if you're wondering what the white thing is here, that's just a twist tie. When you buy the commercial dew heaters, they usually have an elastic band and Velcro or hook and loop that's being used to enclose it or lock it in place. I thought about that, but I decided not to go that route. All the times that I've used this dew heater to date, I've just snapped an elastic band around it, and that's been fine. But I found a really long twist tie, so that will work as well. So lots of things here. The final, it's all but done. The final thing that I need to do is just hand sew just in this area. And I'm going to put a few threads through the plastic or the rubber sheath there of the power cable, just to lock everything in place. But it's done, it works really well. I'm really happy with it. And again, for me, it didn't cost anything. So if you're not a do-it-yourselfer, if you're nervous about any of these steps, if the math is unclear to you, I strongly recommend visiting our local Toronto astronomy accessory vendor, Kendrick Astro Instruments, and the 2-inch heater is around $71 Canadian. I looked at the website just recently, so those are the prices as of now. Kendrick used to make kind of an economy series called the Firefly heaters, but I don't see those on the website anymore. So I think those are discontinued. And you can see by the website snapshot that they've actually dropped the prices for the premier heaters. So they're a bit less expensive than they used to be. So again, apologies to Jim Kendrick. I'm not trying to undercut anybody, but for me, I'm doing multitasking. I've got my Kendrick 8-inch dew heater for my big telescope. I've got the Kendrick controller that drives that. I used to have a Kendrick 2-inch eyepiece. That's dead, doesn't work anymore. So I've made my own. And if I want to run my camera at the same time, I need another dew heater. So I'm going to build a couple of these to use for my eyepiece and my camera lens. If you have an imaging rig, you need a heater for your objective or for your secondary mirror. You need one for your guide scope, maybe one for your finder as well. So invariably we need 2, 3, 4 heaters maybe. If you're really serious about this and you want heaters for your binoculars, you need 4 right there for the binoculars. So it's kind of amazing when you start to add it all up, how many that you need. I've made all the information about my build, detailed information, available on my website. I list all the supplies and parts and consumables in detail, and I explain all the steps. And I have links to my specific blog site, blog articles that have photos and detailed information there. So it's kind of an online how-to guide. If you use that website URL, that'll take you to the article with all the detailed build information. If you have a QR code reader on your phone, you can scan that code. It will take you to that article. Again, apologies to Jim. He's a nice guy. He's helped me out a lot. But if you're on a budget, if you need lots of dew heaters, if your current dew heater has broken or failed, or you need more to do multitasking, and you are good with a soldering iron and you've got some of these electronic bits around, then you might be able to make some pretty easily. So thanks for your time. I don't know. I have no idea how much time I took. So, but if we have time for questions now, I'm happy to take those. I've got my email address there. So if you have a follow-up question after, I'm happy to do that. I hope that you can keep your telescope nice and warm, but not too hot, and that will help you observe all night long or image all night long. Thanks.
Thank you, Blake. Let's go to some questions. Ennio, do we have any?
So we have a comment from Eric who writes, protection of dew is important, but a heater, in my humble opinion, is not your first line of defense. A dew cap uses no electricity, has no wires, and baffles straight light. That's the thing. Reduces reliance on heater.
Yeah. I have a dew shield, and my finder scope has an integrated shield, and when you use a Newtonian telescope, you kind of have built-in shielding for the primary mirror. And if you have a camera lens with a hood, an extendable hood, that all that helps. And there's a rule of thumb when you have a dew shield that it should be at least 1.5 times the diameter of the telescope tube. So if you have an 8-inch telescope and you put a dew shield on it, the dew shield should extend out 12 inches, right, or more. I put a foam wraps around a telescope to serve as dew shields. I've used cardboard, thin cardboard to wrap around a telescope, snap an elastic band on it, acts as a dew shield. So that's great. And again, no muss and fuss in terms of electricity or power. But there have been many a time where even when I've done that, I've been wiped out after a couple of hours. A place that comes to mind is just about every time that I went to Mew Lake in Algonquin and we observed beside the beach. Of course, then we're asking for trouble. But every time that I was at the park observing in September, people were getting dewed out, and I needed my shield and my dew heaters, and I had the dew heaters running at full blast. And the shields that we're talking about are a great idea and may keep the dew at bay, but that's only working at the front of the telescope. So my whole thing here was about an eyepiece heater, where, you know, if that's exposed for any sort of amount of time to a humid, say, summer evening, it's going to dew up. And I've found in the wintertime that eyepieces get so cold that the heat and moisture from my eye and my face make the eyepiece fog up. And I can't stand that when there's fog on the eyepiece. That's just drives me crazy. So I think, with respect, that in extremely high humidity situations, when you're very near or at the dew point, a dew cap will only do so much, and putting covers on an eyepiece or covers on the finder are going to help, but that's only a partial solution. You're going to need active dew heating, I think, in extreme scenarios.
The first question is, could you use peel and stick foil duct tape? And the second question is, should you build a heated eyepiece case?
So those are good questions. When I was thinking about the foil, the reflective foil, which I actually put inside my custom heater, I did think about aluminum duct tape with the sticky backing on it. So that's an alternative, and I think that would work fine. The the way I built it is the reflector where I put the foil was on the outside of the outer perimeter of the heater. And if I used aluminum sticky tape, then the sticky bit is sticking out there. So if you just accommodated for that in your design, that sounds fine to me. I think that would work. So that was on my list of supplies when I was thinking about building this. Do I use aluminum foil or do I use aluminum duct tape? And I went with foil. And I, yeah, that's a great idea. One of these days I'll build one of those. Uh, what I sort of do, I have my eyepiece case, and if I'm out in the open somewhere, I make a point of closing the lid. I know lots of people, they set up all their gear, and many a time I see eyepiece cases sitting open in a high humidity situation, and I think you're asking for trouble there. I close the lid, I have a towel in there, and so on. Now, one day when I was in an electronic shop, I found a sheet, some sort of heating element sheet. I don't know what it's used for. It was just this raw sheet, and it was about 12 inches by 12 inches, wires coming off of it. I hooked it up to 12 volts. It got warm. So I thought, I went, this is great. I bought 2 of them, and I've never ever used it for anything. But that would be maybe a nice thing to build into a case, or maybe just slip inside the cover. And it's got plastic coating on it. It's all sort of insulated, so that would keep the eyepieces warm. So that's sort of a neat idea. Heating right inside the eyepiece case, or having some sort of active element inside the case would be good. But in lieu of that, if you're observing, don't leave your eyepiece case open. As Eric suggests, put all your caps and covers on your eyepieces when you're not using them. Many a time I see people observing and they take one eyepiece out of the telescope, put it on the table, switch to another eyepiece, and it's out in the open. So that eyepiece will get dewed up just sitting there. If nothing else, you just need to cover it with something. So it's not sort of out in the sky in the open air.
No more questions in the chat.
Questions? Okay.
Okay, thanks for your time.
So Blake, to this day, I still don't have a dew heater for my eyepieces. And just a very quick story. A few years ago, I was observing at Starfest, late August, with a Dobsonian telescope. And as you mentioned, you typically don't need dew prevention on a Dob. And sure enough, my eyepiece dewed up pretty badly. And I thought I was out of business. I was done because I didn't have a source of heat to defog the eyepieces. But then it occurred to me that I was running a laptop. So I used the laptop's exhaust to slowly defog the eyepiece.
Yeah.
And that worked just fine. So I kept going.
we do what we got to do. So Starfest, for people that don't know, big star party that happens near Mount Forest in Ontario, and typically in July or August. So prime time sort of weather conditions where it's really hot in the day and then it cools off dramatically in the evening. And invariably the temperatures get very close to the dew point every evening. I look at that when I am planning an observing session. What's the temperature now, sort of in the early evening? What's the humidity right now? What's the predicted dew point? Good astronomy websites, weather websites like Astrospheric, show you the dew point and how close the ambient air temperature is getting to that. And if you're within 2 or 3 degrees of the dew point, dew is going to start to form. It doesn't happen only at the dew point. Dew is starting to form before that. And by the time you're at 95% humidity, if you don't have any sort of heating or a hair dryer or some warm pockets, you could be done. When I started observing, that the store didn't tell me about this. I'd blow my budget anyway, but the store didn't tell me when I bought my telescope, think about dew heating. So I just assumed, because I was on my own, didn't talk to anybody, I just assumed that if you did astronomy, you could only do it for an hour, and then you'd pack up and go home. So that's what I did for the first couple of years. And then I started thinking there's got to be, you know, go for a longer period, longer observing sessions here. And I started learning about passive and active dew strategies. So I got the dew cap. That was the first thing that I got. And that only helped to a degree. And then I started getting dew heaters. And that was night and day. That it just made the whole evening available. So hopefully this is giving you some ideas.
Very good. Thank you so much, Blake.
Welcome.
Excellent presentation, as always.